let's look at the type of the chemical equilibrium. This system that undergo the process of a reaction is divided to two types, which is the homogeneous system and heterogeneous system. Homogeneous system is when we have the same phase of a reactants and product in the system. In our chemical equation, we'll observe that if all components have the same phase, for example, all reactants are gases, the products are gases as well. So if we have the homogeneous equilibrium, we will consider all substance in writing the K expression. However, for the heterogeneous equilibrium, this is when we have a mixture of different phase, different state of the reactants and product in our chemical reaction. So in this case, if we have the heterogeneous system, only the one in the aqueous and gaseous state will be included in our K expression. For the pure solid or liquid, they will exclude from K expression. So let's consider this example. How to write the Kc expression for this reaction? Look at the equation that is given. We have N2 gas react with 3H2 gas to produce 2NH3. Okay, first we have to identify whether the system is homogeneous or it is heterogeneous. Look at the state of the first one, it is gas. Second gas, the third one is also gas. So this is the homogeneous system. So when this is the homogeneous system, when we want to write the Kc expression, we will include all. So Kc is equal to concentration of the product, which is NH3, power of its coefficient divide with the concentration of the N2, power of its coefficient, which is 1, multiply with the concentration of the H2, power of its coefficient. So this is the Kc expression. If we have to calculate the Kc value of the reaction, if let's say we have 0.5 molar of ammonia, 0.2 molar of the H2, and 0.15 molar of N2 at the equilibrium, so the Kc will be equal to, writing the expression first, plug in the value 0.5, multiply with 2, divide with concentration of the N2 just now is 0.15, multiply power of 1, multiply with the concentration of the H2 is 0.2, power of 3. Okay, so we have to follow this. And then press your calculator, then you will get the Kc value. Okay. Firstly, we have to check this is liquid, the second reactant also liquid, the third reactant liquid, and the third product liquid, and the last one H2 also liquid. So this is the homogeneous system. So when we write the Kc expression, so it will be equal to concentration of the CH3COOH, power of 1, concentration of the H2O, power of 1 over concentration of CH3OH, multiply with the concentration of CH3COOH. This is our Kc expression. If we have to calculate the Kc value, then we just plug in the value that is given in the question. So if we have the heterogeneous system, for example, we have this reaction, calcium carbonate decomposed to form calcium oxide and carbon dioxide. Okay, as for this, the one that we'll consider in our Kc expression is the one in a gaseous state or aqueous state. As for this case, we have only carbon dioxide that will come out in a Kc expression. Okay, let's look at two other example. If we have the AgCl solid turns to Ag plus aqueous plus Cl minus aqueous, so the Kc expression will only include the one in aqueous state. So Kc is equal to Ag plus multiply with the Cl minus. And for this one, this is also heterogeneous system. We have a mixture of solid and also gases, and this is solid. So we will just include carbon monoxide in our equation, our Kc expression. So Kc is equal to 1 over concentration of the CO power of 4. Okay, so we have discussed before that the equilibrium constant can be either expressed by using Kp or Kc. So now, if let's say the information that is given to us is a partial pressure, we can convert it to Kc. If the information that is given to us are concentration, after we calculate the value of the Kc, then we can convert it to Kp by using this equation. Kp is equal to Kc RT power of delta N. The delta N means the difference in the amount of the number of mole of the reactant and product. So the number of mole, the total number of mole of the product, which is 2 for this case. If you want to calculate the delta N, we have 2 mole of the NO2, so 2 minus with 1 mole for oxygen plus with 2 mole of the NO. So that the delta N for this case is negative 1. So if let's say the Kp is the one that we want to calculate, Kc is given as 0.2. So Kp is equal to Kp is equal to Kc RT delta N. It is equal to 0.0821 multiply with the temperature. If let's say the temperature of this reaction is 200 Kelvin, multiply with 200 power of negative 1. Press the calculator, then we'll get the answer.